everyone, a while ago I made a video debunking a flat earth video and it did pretty well, so I thought I'd have another go. So here's a video trying to prove that gravity doesn't exist.
The sun is said to be 864,400 miles across.
So at the beginning he states a bunch of figures are set up for the rest of the video, so I'm just going to skip to the part where he begins his argument.
It is also said that it weighs about as much as 333,000 times as much as Earth. Imagine that. We have managed to weigh the sun from here on Earth.
Now I know this isn't the main point of the video, but I think it's quite important to address how we know the mass of the sun, using only our point of view here on Earth. Assuming that the Earth's orbit is circular, which it very almost is, it will be affected by the centripetal force. So here's the equation for that. Since we know that this force is due to gravity from the sun, we can replace the centripetal force with the gravitational force to get this equation. Remember the left side, that will be important later. We'll cancel out the Earth's mass on either side, as well as one factor of r on each side. We can get the value of v squared from the circumference of Earth's orbit over the amount of time it takes to complete one orbit, then square everything. Now, rearranging the equation to solve for the sun's mass, we can plug in all the values from what we know about Earth's orbit and outputs the mass of the sun, which is about 2 nonillion kilograms. Pretty large.
The sun's gravitational pull is what we are told keeps all the planets in their respected orbits. And we are also told that this force called gravity keeps the moon rotating around the Earth. So then the question becomes, when the moon is between the Earth and sun, why does the sun's gravitational pull, which is so great, why does the sun's gravitational pull not then steal away the moon from the Earth?
Now at first, this may seem like a big problem, but when you realise that mass alone is not the only factor that gravitational force depends on, it's a pretty easy point to take care of. You see, it's not just mass that determines the strength of gravity between two objects, but the distance also. Here's Newton's equation of gravity, the same thing used earlier on. The g you see in the numerator is the gravitational constant. It has a value of approximately 6.67 times 10 to the power of minus 11. The m1 is the mass of the primary object, in this case the sun, and the m2 is the mass of the secondary object, in this case the moon. And the denominator of the equation is the radius, or distance between the two objects, squared. This means that the force between the two objects is inversely proportional to their distances. Let's take the example of a human standing on the surface of the Earth. We know the mass of the Earth is 5.972 times 10 to the 24 kilograms, and say the human weighs about 70 kilograms. We also know the radius of the Earth to be about 6,400 kilometers. Plugging these values into the equation, we get a gravitational force of about 10 newtons per kilogram. Applying this equation to the sun and the moon, we get a value of about 4.4 times 10 to the 20 newtons for the force between them. Doing this again for the attraction between the Earth and the moon, we get a value of about 2 times 10 to the 20 newtons. This means that even factoring in the distances between objects, the sun still has a larger force on the moon than the Earth does. More than twice as much, in fact. So why doesn't the sun steal the moon away from Earth? Well, if you actually look at the moon's path around the Earth, and then look at the Earth's path around the sun, you'll see that the moon is orbiting around the sun. But because it's so close to the Earth as well, it orbits the Earth too. So really the moon is in orbit around the sun, and the Earth.
Apparently the sun's gravity is so strong, it can hold much larger planets than Earth in its orbit at much further distances. For instance, Jupiter is said to be so large that it is 2.5 times as massive as the rest of the planets in the solar system combined. So if the sun's gravity can hold a massive gas giant like Jupiter in the 5th position of our solar system, then why can't the sun's gravity steal away a tiny moon that is much closer than Jupiter? Are we to believe that the Earth's gravitational pull on the moon is stronger than the sun's gravitational pull?
Like I said earlier, the moon is in orbit around the sun, similar to Jupiter, the only difference being is that the moon is also in orbit around the Earth. We just have the illusion that the moon is orbiting Earth alone because Earth is our vantage point. But if you were to look at things from an absolute perspective, say above the solar system, you'll realise that the moon is in fact orbiting the sun as well.
Consistencies in the heliocentric model like these easily prove that Newton's so-called law of universal gravitation is entirely false.
Easily prove that Newton's so-called law of universal gravitation is entirely false. Universal gravitation is entirely false.